Hi, everybody. It takes a lot of work to become a parallelogram. Not just any old quadrilateral can become one, but the true elite of the elite are the special parallelograms. They have to work extra hard and fit even more rules. That's what we're going to be talking about today on geometry. So let's get started talking about the properties of special parallelograms. Now, there's a few types of special parallelograms, and the first one is rectangles. Now, what is a rectangle, you may ask? A rectangle is a quadrilateral with 4 right angles. Any quadrilateral with 4 right angles is going to be a rectangle. Now, it's important to note all rectangles are also parallelograms because all the rules that we talked about in the last video still apply. Opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary because 90 plus 90 still gives us 180. So, let's look at some properties of a rectangle. If a quadrilateral is a rectangle, then it is a parallelogram. And this is an important piece of information. If we are talking about a rectangle, then its diagonals are going to be congruent. So if a parallelogram is a rectangle, then the diagonals, or the lines that go from one side to its one corner to its opposite corner, are going to be congruent. Those are the big properties of a rectangle. Now let's talk about a rhombus. What is a rhombus, you might ask? Well, a rhombus is a quadrilateral with 4 congruent sides. All rhombuses are, of course, going to still be parallelograms, but like I said, the major thing with this one is that all of these sides are congruent. So, here are some other properties, though, that we get. First, as we stated before, if a quadrilateral is a rhombus, it is a parallelogram. But then, if a parallelogram is a rhombus, then its diagonals are perpendicular. So, if it is a rectangle, its diagonals are congruent, and if it is a rhombus, they are perpendicular. The diagonals will not necessarily be congruent if it is a rhombus. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So each angle is also going to be bisected by the diagonal. This will be important for later. Now let's talk about a square. This is something I know quite a bit about, as I am one myself. A square is a quadrilateral with 4 right angles and 4 consecutive sides. Since a square is a parallelogram, a rectangle, and a rhombus, a square has all the properties of each. So it has all the parallelogram ones. It also means that all of its angles are 90 and all of its sides are congruent. So that also means all of the properties are there. The diagonals will both be congruent and will intersect at a 90-degree angle. The diagonals will also bisect each angle. So a diagonal will cause each angle to be 45 and 45. All right, so now let's try it and see what happens. Here's our first question. It says, the vertices of square STVW are S at 5, -4, T at 0, 2, V at 6, -3, and W at 1, -9. Show that the diagonals of square STVW are congruent perpendicular bisectors of each other, because that's what it means to be a square. So the first thing I'm going to do is I am going to, just for the ease of us seeing it better, kind of sketch out where these points are. Remember, I don't have an actual sketch. I don't have an actual grid here. I'm just kind of doing it on my own. So -5, -4. That's going to be S. 0, 2. That's going to be T. 6, -3. That's going to be V, and then 1, negative 9. That's going to be W. So S to T. So what I'm going to do is I'm just going to talk about the diagonals because that's all that really matters here. So our first one that we're going to deal with is this S to V diagonal. What we want to do is we want to find its slope, but we also want to find what the actual change in X and the actual change in Y are. So in this case, let's see, S was at 5, negative 4. So 5, negative 4. And V was at 6, negative 5, sorry, negative 5, negative 4. And then at 6, negative 3. So let's see, the distance from negative 5 to 6 means horizontally it'll be 11, and then negative 4 to 3 is going to be 1. So change in Y is going to be 1 over 11. That's going to be our slope. Now let's look at TW. So with TW, T is at 0, 2, and W is at 1, negative 9. So let's see. The change from 0 to 1 is just 1, and the change from positive 2 to negative 9 is we went down 11, meaning the slope of TW is negative 11 over 1. These are opposite reciprocals of each other, which means that they are perpendicular. Now let's talk about our second piece of information that we actually need, though. We need the distance. Now I will point out that our change in X and change in Y are already there, which means we can actually say that this one would be the square root of 11 squared plus 1 squared, or the square root of 122. And over here, we would have the square root of 1 squared plus 11 squared, which hopefully you already know is going to also be 122. So on both of these, it is the square root of 122, which is going to be just so slightly over 11 that it's basically 11 at that point, but not quite, which is why I'm going to just say they are also congruent. So that is enough to show both of those pieces of information. Now let's look at our next one. We are given that PQTS is a rhombus with a diagonal of PR. We are out to prove that RQ is equal to RS, meaning the distance here is going to be equal to this. But we don't know that yet, so we can't actually mark it up like I just did. So the first thing that we need to do is we need to actually establish that these two, we need to establish something that would prove it. So the thing is, there is another piece of information we know. We know that PR is congruent to PR. And that is because of, say it with me, reflexive property. We also know that this is a rhombus, which means PQ is congruent to PS. That's because of the definition of a rhombus, and also, in this case, it's already in the picture, so you could say given. But then for the last piece of information, I am going to point out that angle QPR is congruent to angle SPR. And that is because we said that a diagonal will bisect both sets of angles. So for instance, these would also be congruent. So what we have here is a side, an angle, and then another side. So that's an included angle. So we would say side, angle, side is the reason, which is how we know that those two are congruent. At which point, if those are congruent, then that also means that QR and RS have to be congruent, and that would be because of CP, CTC. All these things back from the first semester. So exciting. I know I am just overwhelmed with it. I'm so excited. I'm so excited. I'm so scared because it's proofs. All right, let's move on. because we're now going to be talking about the conditions that we can use for special parallelograms. In other words, these are the things that now we could use to prove something is, say, a rectangle, a rhombus, or a square. These are going to be very similar to what we just talked about, but let's first talk about the conditions for rectangles. If one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So if I have a parallelogram and just one of the angles is a right angle, then that parallelogram has to be a rectangle because the opposite angles will be congruent and the consecutive angles will be supplementary, meaning all of them have to be 90. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if we have any parallelogram where the diagonals are congruent, that only works when it's a rectangle. Now let's talk about the conditions for rhombuses. If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So if we know it's a parallelogram and any pair of consecutive sides is congruent, then all four have to be. Now, if the diagonals of a parallelogram are perpendicular, then the parallelogram also is a rhombus. So basically, if the rule that we just learned is the case, then it has to actually fit that, as long as this is a parallelogram. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is also a rhombus. It is very important that we note that all of these are only conditions for rhombuses if the figure is already known to be a parallelogram. If it is just a quadrilateral, then we cannot prove that it is a rhombus. It is possible it will be a kite, and we are not talking about kites today. We talk about them next time on geometry. So now let's apply some conditions for special parallelograms. Oh, wait, you might be asking, what about the square? This has the conclusion it's a square, but we didn't talk about it. Why would that be? The answer is very simple. With a square, it has to be at least one condition from rectangles and one condition from rhombuses that would prove it. So in this case, let's look. This says we are given that AB is congruent to CD. So I'm going to mark that up right now. AB is congruent to CD. We are also told that BC is congruent to AD. All right, these two pieces of information right here together prove that it's a parallelogram. So right here, we have proven it's a parallelogram. As you might remember from the last lesson, parallelograms are, if you ever have a quadrilateral where opposite sides are congruent, it is a parallelogram. Now, let's talk about our next piece of information. What we have here is that AD is perpendicular to DC, which would be this right here. This proves it's a rectangle. So I'm just going to write rect right here. And then we are told AC is perpendicular to BD. That means our diagonals are congruent, or are perpendicular, sorry. That proves it is a rhombus. So if we know it's a parallelogram that is both a rectangle and a rhombus, then our conclusion right here, ABCD is a square, is correct. So there we go. So now let's identify special parallelograms in the coordinate plane. So we are going to use the diagonals and not the sides to determine whether this parallelogram with the given vertices is a rectangle, rhombus, or square. We are going to give all the names that apply. Please note, we already know this one's a parallelogram, so we don't have to prove that. We just have to prove stuff with the diagonals. So we're going to start with sketching it out. 0, 2, 3, 6, 8, 6, 5, 2. Okay, so that actually does make sense. If you look, these are definitely going to be some form of parallelogram. So now what we need to do is we need to determine what type it is. I'm going to already just outright say it's definitely not a rectangle, but we're going to prove that in just a second by doing this. So we're going to go with figuring out A, which is at 0, 2, to C, which is at 8, 6. So the diagonal here, we have a run of 0 to 8, which is 8. And we have a rise of 4. So 8 and 4. Now, before we actually go into that, let's talk about B and D. B is at 3, 6. And D is at 5, 2. So in this case, we have a rise of, let's see, from 2 to 6 of 4, except it's actually going down, so negative 4. And a run from 3 to 5 of 2. So our two slopes in this case are 4 over 8 and negative 4 over 2. This ends up becoming, so this ends up becoming a slope of 1/2, whereas our other one is negative 2 over 1. Now they are not going to be congruent, which means it is not a rectangle and therefore not a square, but they are perpendicular because they are, in this case, going to be opposite reciprocals, which means it has to be a rhombus. All right, we're going to do this one more time. E is at negative 4, negative 1. F is at negative 3, positive 2. So negative 3, positive 2. All right. G is at positive 3, 0. And then H is at 2, negative 3. Now you might already be able to tell, just from this little sketch, what type it likely is, but what we're going to do is we're going to figure it out. So in this case, what we have here is we are going to use our slopes to go, let's see, so negative 4 to positive 3 is going to be 7 and up 1. And then we are going to go negative 3 to positive 2. That's going to be 5. And then 5. So this goes down 5 and over 5. So what we have to do now is we actually have to do Pythagorean theorem or distance formula. So change in x was 7 squared plus 1 squared. That is 49 plus 1, so the square root of 50. And then if we go on the other one, that is going to be negative 5 squared plus 5 squared, which becomes 25 plus 25, which is also square root of 50. Wait a second, those are equal, which means it has to be a rectangle. Now, if you look, you can already kind of tell it's definitely not a rhombus, but also if we did the slopes, you would see one of them had a slope of 1/7, the other had a slope of negative 1. Very different slopes, which means it is only a rectangle and not a rhombus or a square. And there we go. That is it, I believe, for this lesson. So what we're going to do now is I'm just going to remind you of the most important thing that I can ever remind you of in any lesson. And that's not to take your notes, not to do your homework. No, the most important thing is to tell you to like and subscribe. That's right. Please like and subscribe, comment, all of those things. Thank you all very much. Have a wonderful day. Goodbye, everybody.